What is the least possible length of a side of a triangle whose perimeter is 2002 and whose sides have integral lengths? Well, since it's question number 1, it's probably going to be pretty straightforward. They're saying you've got some triangle, and what is the minimum? Well, let's see if the minimum could be 1, because they're integers, so the minimum integer obviously is 1. If this is 1, then the other two sides would have to add up to 2001, right? So we'll say 1000 and 1001. That would make a perimeter of 2002. But here's the problem. This fails the triangle inequality. The triangle inequality states that two sides have to be greater than the third side. So this side and this side, for example, 1000 plus 1, that equals 1001, so it's not greater than, so that fails. So let's try another scenario. Let's try 2. If 2 is this the length of one side, then the other two sides could be 1000 and 1000. And that's just a standard isosceles triangle, and that definitely passes the triangle inequality. So with a little bit of experimentation, you can say that the minimum length of one side is 2. Of 50 students, 20 take art and 25 take music. If 10 students take both subjects, how many take neither? Well, we can do this in a Venn diagram. Venn diagram. And here we go. So we got one circle, and this first circle will represent the art students, and the next circle, music. And we'll label it, so we'll put A for that, B for that, which is the region in between, and then C, and then D is neither. So based on our question, A plus B plus C, all the students are 50. And then A plus B, A plus B is the art circle, that's 20. And then B plus C, that's the music circle, and that is 25. And then we are trying to figure out neither, so basically we're trying to find D. Okay, that shouldn't be a problem. So let's see here. What's the first step? Any other questions? Oh, if 10 students take both subjects. Okay. So that means 10 students. So B is 10. Okay, that's very helpful. So if B is 10, then I can sub that into there and get C is 15. And then I can sub all that into here. So A plus B is 20, so that's 20. C is 15. And then I can just solve for D. All right, so when you do that, you'll get D is equal to 15. And that is the answer. What is the only number x greater than 0 which satisfies this equation? So we have x to the exponent negative 1 plus root 2. And then we have x to the exponent negative 1 minus root 2. And that is equal to 16. So using exponent laws, you add them. You add this guy and this guy. And when you add them, you'll just get negative 2. Because the roots cancel. So then we have 1 over x squared is 16. So that would mean that 1 over 16 is x squared. And then if you take the square root, you get 1 over 4. And then x is greater than 0, so that is the only one that is valid. The roots of x to the power of 3 plus 6x squared plus 4x plus 2 is 0. Are Rs and T. For what ordered triple of integers ABC are 2R, 2S, and 2T the roots of x to the power of 3, ax squared plus bx plus c? Well, we have two equations, this one and this one. And the first one, x to the power of 3 plus 6x squared plus 4x plus 2, they're telling me the roots are R, S, and T. Now we can expand this, but I'd rather use Vieta's. It's a little bit cleaner, a little bit faster. Vieta's formula on cubic functions. And if you don't remember it, then you can just expand. But I remember it. And that states that the sum of the roots are equal to, if the roots are, R, S, and T, the sum of the roots of a polynomial of the form ax to the power of 3 plus bx squared plus cx plus d, the sum of the roots would be r plus s plus t, of course, but from this you can calculate it as minus b over a. Okay, whatever those coefficients are. And then the product of the roots, if the roots are r, s, and t, obviously the product is r times s times t, but using Vietas, it is minus d over a. And then you have another one called sum of products. Sum of products is basically as follows. It's rs plus rt plus st, and that is c over a. So let's apply that on that equation. So let's see here. Let's see what we get. So if I use minus b over a, so this is my b, and this is, but the a is really just 1, right? Because that coefficient is 1. So that's going to be minus 6. Product of roots, d over a, minus d over a. This is my d, so it's going to be minus 2. And then the c over a looks to me like 4. So that, and that are minus 6, minus 2, and 4. Okay, so now we turn our attention to this guy. That one. That one is x to the power of 3 plus ax squared plus bx plus c. And the same kind of story, it's sum of roots, which these are the roots this time. So I'd rather keep it in the same screen. So that would be 2r plus 2s plus 2t, and that is minus b over a, this guy. But be careful, this is sort of the b this time, and the a is this guy. So that would be minus a, correct? Yeah. Okay. Okay, product of roots, so that's 2r times 2s times 2t, and that's minus d over a. So this is my d this time. So that's going to be minus c. All right. And then sum of products, so that's going to be this time 2r times 2s plus 2r times 2t plus 2s times 2t, and that is going to be c over a, so that's b over 1, so that's just b. Okay, so that really helps us. So let's see here. This is equal to 6, right? So this guy, which is 2r plus 2s plus 2t is negative a. If we factor out the 2, we get r plus s plus t, correct? And r plus s plus t is minus 6. So we got 2 times minus 6 is minus a, and therefore a is 12. In a very similar way, we'll use this and this being equal to minus 2. So we have rst is equal to minus 2. And then this tells me that if I multiply that, that's going to be 8, right? 8 rst is equal to minus c. But rst is minus 2, so that means c is equal to 16. And then finally, of course, we're going to use this one, and then this one, that one being equal to 4. So rs plus rt plus st is 4, but then this tells me that that's 4rs plus 4rt plus 4st is equal to b. Factor out the 4 and you'll just get the rs plus rt plus st, and then this is equal to 4, so just sub that in, and then therefore b is equal to 16. Okay, so therefore finally our triple ABC is 12, 16, 16. When evaluating log A over log B, Pat mistakenly thought that log A over log B is equal to A over B. For what ordered pair of real numbers AB is Pat's result 2 over 3 correct, thereby legitimizing an otherwise improper cancellation of log? Log of A over B, now they don't give a base, so that's just assumed to be base 10, is A over B, and they're saying that is equal to 2 over 3. Okay, so first let's concentrate on that guy. That's going to give me 3a is equal to 2b, and therefore a would be equal to 2b, 2 over 3 times b. Okay, and then let's go back to this. So that's the log of a, which is, let's just substitute that in, 2 over 3 times b, all over the log of b. And then using log rules, this is the log of 2 over 3 plus the log of b over the log of b, correct? And then I think that, well, that's equal to 2 over 3. So then now let's use these two cross multiply. So 3, the log of 2 over 3 plus 3 times the log of b is equal to 2 times the log of b when you cross multiply. And then using log rules, this becomes log of 2 over 3 to the power of 3. And then that becomes minus log b. Using log rules again, that's log of b to the negative 1. And this remains the same. We can just do it. It's 8 over 27. So the bases are not written, so they're assumed to be base 10. The bases are the same, so therefore this 8 over 27 is equal to b to the negative 1. So that means b would just be 27 over 8 because you just invert it, whatever the term is. And then to figure out a, that's pretty straightforward. A would be 2 over 3 times b, which is 27 over 8. And that looks to me like 9 over 4. So my AB is equal to 9 over 4 and 27 over 8. For all real numbers x, let f be a function that satisfies the equation x f at x plus f at negative x is equal to x to the power of 3. What is the value of f at 2? So I think we're going to have to do a little bit of experimentation with this. Let's try. When x is 2, what happens? So it becomes 2 times f at 2 plus f at negative 2 is equal to 2 to the power of 3, which is 8. And then let's see what happens when x is negative 2. It'll be negative 2 times f at negative 2 plus f at 2 is negative 2 to the power of 3, which is negative 8. Let's call this equation 1. Let's call this equation 2. And I'm really just interested in f at 2, right? So if I can get rid of the f at negative 2, then I will be able to solve this pretty quickly. So what I can do is I can do 2 times equation 1, just add to that equation 2. And that would give me 4f at 2 plus 2f at negative 2 minus 2f at negative 2 plus f at 2. And then on the other side would be 16 minus 8. So as planned, that f at negative 2 disappears. So then we just have 5f at 2 is 8, and therefore f at 2 is 8 over 5.